All right. Hello, everyone. I'm Dennis, and we are starting our stream now. Hopefully, we can do it a bit better this week as we are just getting set up here. And hopefully, we don't have that very long period of about half an hour. Again, sorry about that, but hopefully, I can get this all stream set up in about 1 minute. And then this stream today, we are going to be covering object creation. So we're going to be covering on, let me make sure my mic's working. Yep. We're going to be covering on object creation. So what we're going to do this stream is we're going to make an object in Fusion 360, and we're going to slice it in Cura, send it to the printer, and print the object that we design live in Fusion 360. Sorry about that. You don't have to use Fusion 360 for object creations for our printers for generating STL files. There's dozens of different CAD, computer-aided design software platforms out there. And that's one we're just familiar with. We can give a couple little tips and tricks with Fusion 360. And for the slicers, we support Cura and Simplified 3D. And by support, I'm referring to the slicing profiles. So in 3D printing in general, slicing settings are extremely important. For plastic 3D printers, they have a heated nozzle tip and, different layer heights and things like that. And for our printer, we have a 5mm nozzle, a very big nozzle in 3D printing terms. And slicing settings need to match that, as well as how fast print speeds are, how much layer height is. So each layer, so like when you do one layer here, and then the next layer up, and then the next layer, how high, how thick each layer. For our printers, 1.5mm is a very good layer height. So each layer is 1.5mm layers tall. Compared to plastic 3D printers, their layer height can be like 0.2mm. We do 1.5mm for clay with about a 5mm nozzle. And that can get even bigger. You can even go to 2mm or 2.5mm on the layer height. Let me just make sure, is our Instagram stream running? So Instagram stream's just not quite running, so let me just go double check that real quick. Sorry about that, everyone. It should be up. Oh wait, let me just get that. And we'll start designing our object and making sure it's working. Looks like the Instagram stream's a little bit just black there, but in the meantime, we're going to start designing our object. I'm just going to be starting in just a moment. Yes, our Instagram stream did not connect. So unfortunately for this stream, it looks like we're just going to be streaming on YouTube and Facebook. So thanks for everyone for tuning in. And we're going to jump right into our Fusion 360 here. Okay, there we go. So here we are in Fusion 360. So here in Fusion 360, we're going to be designing our STL object. And then we are going to be sending that to our slicer, sending it to the printer, and we're going to be doing it. So let's actually just get right into this. So this is Fusion 360. And there are many, many, many ways to design objects in Fusion 360s. You can say there's no one right way. I'm going to show you some very kind of intro stuff to get into it, and we're going to make a pot and do what I said we're going to do. So here in the tools here, in the top left, let me see if that can be seen on stream. Yes, it can. So we're going to make a sketch and convert that sketch into a 3-dimensional object, and then we're going to export that. So let's go ahead and click on Create Sketch in Fusion 360. And then in Fusion 360, you have to select which plane you want to do. So here's the Z plane, the X plane, the Y plane. That is not too important. So we're just going to select one of them kind of arbitrarily. And you can use your mouse controls to move the plane around. And we're going to look at the top view here and just rotate it. So the tool that would be one of the easiest tools to use would be the line tools and then a rotate extrude tool. Like I said, this is not the only way to design objects, but this is just a very simple kind of intro basic way to do here. So here on Fusion 360, I've clicked this line tool, and I'm going to make the line out a set amount. So let's do 75 millimeters. So 75 millimeter line here. Hope that's in millimeters, but it's okay. We can change that even if it's not. And then we can click back on top. We'll draw another line. This will be the kind of center-ish of the vase, and we'll make that 200. So this vase is going to be 200 millimeters tall. And a base of this. So then let's use this curved line. So we were just making straight lines there. And now we're going to drag our little fit point spindle line and make a couple points here. So this allows you to do very curvy objects like this. And so this is just a very artistic flair here. There's no set exact way to do this. You know, it's to whatever you would like it to look like. So we'll select the bottom. We'll move straight up. And then you can completely design it however you want it to look. So maybe a little bit lower first. Just trying to find a good shape here. Maybe we'll move it out. Sure, that looks fine. Let's go ahead with that shape. So this curve, we're then going to switch to the line tool, and we're going to finish this shape. So now this whole area has turned a little light blue color because it's a kind of finished shape that's enclosed. And we're going to click on Finish Sketch, and now we have this profile. And one of the tools here in Fusion 360 is the Revolve. So we are going to revolve this object in a 360-degree orientation around a particular axis, and we're going to select this middle axis, and there we go. And so now we have a full object that's just generated by Fusion 360 just from a couple tools here. So, you know, we just used the sketch tool to design this shape, and it was just a simple three straight lines and then a curved shape, and then you do a 360-degree revolve rotation around the center point, and a vase is generated. So for this vase, it could be called completed if you like the shape, and we need to get this into a slicer. Our printers and all 3D printers cannot interpret this object. This is a model file. So we're actually going to do that. We'll go to File here and click on 3D Print. Fusion 360 has a cool little 3D print option here. All this does is it generates the model file. So here you can select what the refinement options are of how high quality. I personally always choose the high quality option to keep it a high quality object. And I'm actually going to save the file here. So I'm actually going to save this, and I'll call this vase 1 just for this stream today. So I'm saving that object, and this is saving it as an STL file. And STL files are not fully editable, and I'll explain that when we get into Cura, which we can go ahead and do now. So let's go ahead and switch over to Cura. Okay, so here in Cura, Cura is a slicing software, and Cura takes STL files and other types of model files and slices them quite literally into layers for 3D printers to understand. A 3D printer, including ours at 3D Potter, can't interpret a model file. It doesn't understand it. And 3D printers only understand simple lines of code that says, move up, move this way, move down. And so that's what a slicer does. It takes an object, slices it up, and tells the printer how to move in every direction that it needs to move. So we're going to open our file in this, and you can actually go to File, Open, and Edit for in Cura, or you can actually just kind of drag and drop files into Cura. And here I'm just dragging this vase in now. Okay, and then here's our vase, and it's quite big and it's on its side. So here in Cura, we're actually going to select the object, and then you have all kinds of positioning things to choose from on the left side of the screen here, such as its X, Y, and Z coordinates, how big it is, and its rotation. So like I said, in Fusion 360, when you are selecting which side or which plane to make the object on, here it's not necessarily too important because you can rotate the object in Cura. Okay, so here we have the object now in the correct orientation, but this seems a little bit too big for me. I don't want to print it quite this big. So here on the screen here, the gray plane here is the print area of our printer. So I'm taking up a large portion of the print area. I don't want it to be just quite that big. So here you can actually change the scale of the object. So let's go ahead and turn that back down to 80% scale. It makes it a little bit less, maybe even a little bit less, maybe 70% scale. There we go. So now it also tells you the approximate size of the object. So Z 140 millimeters, so that's 14 centimeters. So the object is going to be 14 centimeters tall. And that's okay for just this demonstration. The rotation is good. The position for our printers is always going to be in the center here. So in Cura, at least for the object position here, this is a property of Cura. When you type 0 for the object position coordinates, it will actually put it in the middle for our standard Cartesian profile printer. So you can see I can drag this around, but when it actually gets sliced, the coordinate is not 0, 0. It's just the object placement coordinates for our Cartesian printers. The SCAR printers are a bit different, but that's some more complicated. We're not going to get to that in this stream. Okay, so now that our object is how we want it to be, we've generated it in Fusion 360, brought it here. Let's check the slicing settings. And here on the right side, these are the settings that control how the printer operates. And like I said earlier, the layer height here is extremely important. In Cura, they even give you cool little descriptions. The layer height, the height of each layer in millimeters. Higher values produce faster prints in lower resolution. Lower values produce slower prints in higher resolution. And that is very much the case here. And 1.5 millimeters is about an ideal for our clay. So we're just going to leave that at that. The line width is 5. That looks good. Wall thickness is 5. We have a 5 millimeter nozzle, and we want to keep that the same for simplicity's sake. You can do some tricky stuff by changing these values to not be the same, and you can get some interesting thickness on wall effects, but we're going to leave that all the same. Top and bottom layers, 0. If you're printing directly onto a clay slab, that should definitely be 0. So I'll show what that means right now. So let's actually see. You can click slice, and then at the top here, there's a button that says preview, and we can see how this is going to print. And here it looks very good. So it has a very good printing profile here. And then on the right side, there's another little slider here that you can drag up and down in Cura. And it shows the full print path of how the object's going to do. And as you can see, there is no bottom layer, and there is no top layer. So if we actually change this So bottom layers, let's say we want 3 bottom layers. That's a decent amount for clay printing. And we reprint. It will now produce the base of the vase for you. And this setting is good depending on your material type. So there's many different kinds of clays and porcelains and earthenwares, and sometimes this prints very, very well, and other times you'll have to tweak the settings a bit to get it just exactly how you want so the vase doesn't crack when it's being fired. But we are going to turn this to 0 for today. When I said we support Cura and Simplify 3D, what I was referring to was this printer profile. So when you click Upload Printer Profile, all of these settings that we're looking and tweaking on the right are changed to what we consider ideal settings. So moving on, we have the infill density here. We're going to keep that at 0%. So as you can see here in the middle of the object, it's completely filled in. It looks like it'll print a solid chunk. But since infill is at 0% with our printers, it slices very well. So as you can see here in the printer, all of that infill just goes away. Material flows 100%. Our printers are tuned to have a good flow rate, so you shouldn't have to change the flow rate unless you're doing some extremely different nozzle sizes or some special printing. Printing temperature is 0. We don't use a heater. Print speed is very important. Slow speeds are good. 30 to 40 millimeters per second is an ideal printing speed. You can get really crazy and go really, really high. You can go even the speeds as fast as 200 millimeters per second, but that's a danger of your print quality being lower than what it's supposed to be. It won't look as good. But if you really are on a time crunch, you could really crank that up. Travel speeds, that looks okay. Let's see, cooling, we don't need any cooling, we're printing clay. Support, we don't want any support. Skirt and trim layers. So on general plastic 3D printers and our printers, we consider this extremely important. So as you can see here, on the very first layer, there's these 2 layers here. And this is the skirt layer, and here you can see we have the count to 2, the distance, and the distance from the object. So for our printers, this helps with priming the extruder and making sure the flow rate's good when we get to this first layer here in the middle here. And with plastic 3D printers, it's good for them because some plastic is kind of old and crusty, and just getting rid of that is very beneficial to plastic 3D printers. So we have a similar thing too. The same thing, the clay can be a little bit old and crusty on the end of the nozzle, and you want to kind of get rid of some of that. And one of the most important settings of all for our printers is spiralize outer contour. In Cura, it's called spiralize outer contour. In Simplify 3D, it is called vase mode. They do the exact same thing though. And what that is it is exactly what it sounds like. This whole vase is now a spiral. Instead of it doing 1 layer, then move up, 1 layer, move up, 1 layer, move up, 1 layer, move up. It will instead do a very smooth corkscrew spiral up through the whole vase. And this is very good at hiding the seam. So if you notice, you can kind of see this seam here. This seam should be somewhat hidden when the print is going. This seam is probably from an inaccuracy from my Fusion 360 drawing, or maybe I didn't do something quite correct there, but it should be relatively hidden because we are doing spiral mode. So, okay. So once you have a good object here in Cura, and I define a good object as you don't see any crossovers or a bunch of infill being made here in the middle or something crazy going on, or the print prints in one spot and then moves over to a different spot. That would not print very well unless you're using retraction. In this case, we're just going to go straight up. So we're actually going to save this. We're going to save this to our files, and we're going to upload it to the printer, which I'll show here as well. So let's go ahead and click Save to File. And I'm going to put that in my little work folder here, and we'll call it vase for stream. And this is now making a G-code file from Cura. So we had an STL file in Fusion, or we generated one from Fusion, brought it to Cura. Cura takes it and generates a G-code file. So we'll save that. And we're going to click on Open Folder, and we're going to switch to our printer, which is up front. Okay, and here we go. Okay, so this is the printer here and up front. So this printer right here in the middle of the screen, we're connected to it wirelessly. And we're going to click on Jobs. And here on the right side, there is a Upload G-code file button. And I'm going to navigate to where the vase was. I'm finding it here in my folders, vase for stream. I'm going to click on Open, and the file is uploading. Just takes a second. There we go. The file is uploaded. And we're actually ready to just click here. We could just click on here and click Yes to start the print. But first, we need to get the printer ready. So let's switch back to the front and let's get that going. Any questions? Okay. Hello. And let's get this going. So I'm going to open the printer interface here, and I'm just going to run our prime program. So this prime program is just good to get the cylinder primed. So when we start printing, it just starts printing right away, and it's pretty much a required step for our printers. It just takes just a moment because I haven't primed this yet for today. Ooh, there we go. You can see the clay is coming out there. And on the interface, I'm going to hit a little stop button, or if you don't want to hit the stop button, you can just turn the power off and on real quick. And it looks like the nozzle needs a little bit of cleaning, so we're going to do that right now. There we go. I just took a small little metal tool and just cleaned the nozzle a bit there. Okay. So we're going to select our vase for stream today and hit yes on the print. So there's a little extra prime here. That's a script I have in our Cura profile. Let me get this camera adjusted a little bit better here. Sometimes adding a little bit of water here, so we're already past it, but sometimes adding a little bit of water to the build plate can help. Oh, yes, we need it right now. Can help the clay adhere. And sometimes helping it along with your hand manually like this can be a big assistance to the actual clay adhering together for the very first couple layers. There we go. And our flow rate in our Cura profile was set to 100%, and it is tuned for a 5mm nozzle, which is what we have here on this printer right now. So this flow rate is what we consider the ideal flow rate for our printers. You know, you can increase it if you want thicker walls, You can always increase it more and things like that. So now that this is printing pretty good, I'm going to switch back to the web browser and show you real quick on increasing the speed. So here you can see on the screen, we're going to increase the speed controls. There we go. So here we have a speed slider. I'm going to click this little plus option here a couple times, and this will increase the print speed. Also, if you see in the top left in the status, it says the top speed and the requested speed right here. So you can, it gives you, very live feedback on how fast the print is going. I'll just leave it at this speed here. So we're printing at 40 millimeters per second. I've set the speed to 150%. Oops. And so now we're printing at 60 millimeters per second. So 50% faster. This is also the same tube of clay we prepared on last stream using our hand loader right here. It's just off camera just a little bit, but that was the same exact tube of clay. We have not wrapped it up or anything. All that was needing to be done was just a little bit of cleaning the nozzle a little bit. It didn't need to be vacuum sealed and all this stuff or put away. And so it was fine just to be sit here on the printer for 2 weeks, and you can just start it up again right away. Let's get this going even faster. Let's go. Let's see how fast we can get this guy going. We're now moving at 80 millimeters per second, so this is double the speed that we requested in Cura. Let's go even faster. We'll keep it at that. We're moving at 100 millimeters per second now. So this is what I would at least define as being pretty much the upper safe end for quality prints. Of course, you can always really, really get there and going fast if you would like it to. But it does take just a little bit of time. Cura estimated the print time, I believe I saw on the screen. It said 13 minutes? Oh, is my mic on? Better be on. Yes, my mic was on. And so 13 minutes it estimated, but since we're moving even faster, it's going to be even less than 13-minute print. And even here on the interface, it actually gives you some cool time estimates of on the time. So you can see here, file progress and how long it needs for the whole file to finish. So it says another 3 minutes and 42 seconds there, estimation on how long until the file is actually done printing. I'm gonna check the streams real quick. Do you know if we've gotten any questions yet this stream? So let me go ahead and check all the chats real quick. None? None? Okay. Sad. I hope more people will get more interested in our stream in the future. Chat app. It's okay though. We're gonna keep streaming and we're gonna keep showing how to use our products in the most effective way. We just had a little air bubble explosion there. So a little air pocket was stuck in the tube, either from us extruding the clay into the tube, or somehow a little air bubble was in from the manufacturer, and then it just causes a little mini air pressured pocket explosion. And that can, you can try and clean it up by hand or anything, or maybe even after the vase gets fired once, you can actually use sandpaper or other tools that you would normally use with just vases in general, not 3D printed vases, but a vase that was spun on a pottery wheel. It'd be treated the exact same way. So here near the end of the print, I'm going to slow the speed back down near the end of the print to reduce some pressure in the tube. So the retraction script for the end of the print can retract the clay fast enough. If the print's running very, very fast, then the tube pressure is high. Therefore, near the end of the print, clay will still be coming out. So I'm just reducing the print speed, which is also the extruder speed, back to what we said in Cura, which was 40 millimeters per second. Here we go. So here in Cura, this is our profile that we provided. The Cura is retracting the extruder and bringing the Z-axis out of the way. And then it just brings the pot forward. So now, you could print another object again and get right into it just by taking the bat off. And you can start your next object right away. I'm going to have an employee come here and assist me. No? Would you like to help me with this object here while it's in stream and on camera? Yeah, just, would you like to oh no. Little Yeah, so that clay, it's still perfectly good clay, and you can throw that back into a pug mill or throw it back into your hand loader and reuse that clay again. And so now that we have a brand new bat that I promise is not the same one at all, this is a completely different one. We still have that pot completely ready to be used. Okay. But yeah, so that's the basics of Fusion 360, Cura, and actually printing it live from start to finish. Unfortunately, I don't think we had that many questions this stream. So pretty much that's going to conclude our stream there, I believe. So thanks everyone for tuning in if you're watching. And yes, so we are going to be accepting, if you're watching this stream, you can email us your STL files if you want. So yeah.
All right, Dennis, I do have a question.
We got a question.
How do you fix an imperfection mid-print, for example, a small bubble?
Okay, so that's a bit tricky. So fixing imperfections mid-print. I would definitely say you'd have to wait for the print to be finished because the piece is moving around and everything. So once it's finished, if it's a small imperfection, you can use small metal tools and small clay carving tools after a print's done to work on the piece manually. Personally, I would think you would wait for it to start drying up a bit, get to the greenware stage, maybe even wait until bone dry, or even after firing it perhaps, depending on your material type, and to actually manually try and beautify any imperfections.
Okay, that's it. Don't forget to submit.
Okay, yeah, submit STL files to stream@3dpotter.com. That's an email address. Just email us any STL files. If there's an interesting one, we'll print it and slice it on stream. Okay, see you guys in the next one. Thank you for everyone and tuning in.